Hi, this is my Lab 4 for EE319K. It's a microcontrollers class. What I have here is a traffic light, or two traffic lights and a walk light simulating a intersection in the real world. To start with, the brains of the whole thing is a Freescale 9S12 microcontroller, and it's on a PCB built by Technological Arts. The board is there to help interface the inputs and outputs. I don't know, students like me can play around with it and learn how to program the microcontroller for projects such as this. Basically, we have a circuit here that my partner designed, and it's pretty cool. So anyways, so we have the south lane here, green, yellow, red, and we have the west lane, green, yellow, red, and this light here is the don't walk light, telling pedestrians not to cross the street because it's not safe to do so. And then we have these sensors. This top one is the west lane sensor, and the south one is the this is the south lane sensor for cars, and this is the walk button. So anyways, right now south is green and west is red, and it's telling pedestrians not to walk. So now I'm going to push the west sensor, and we're telling the system to service the west lane. Now we'll push the south sensor and we'll return back to the previous state. Okay, so now we will simulate a pedestrian pushing the walk button. Basically, goes to yellow and the light is off, telling pedestrians it's safe to walk now. This circuit, or this simulation, is slightly different than what you see in the real world. This way you have to have both lights in both directions red before the pedestrians can cross the street. That is just something that the lab manual instructed us to put into our design, so we had to do that. So sort of unreal, but anyways. Okay, so what happens when we push the west sensor? What happens is the light, the don't walk light, flashes to instruct pedestrians to hurry up, that the light is about to change colors. And it does, it goes green. So we'll do one other case. If all the sensors are pushed, we're basically going to cycle through each state, servicing the pedestrians and both lanes. And we're servicing the south. Okay, so it's not truly a first come first served system. It's, for the most part, it is. As you can see, it was just green in the south, and then when I pressed them all, it went to south. That's just something that I guess I didn't spend enough time on in designing, but anyways, it still works. It services both lanes. And where we started with this whole project is we started with what is called a state graph, something I learned how to build in a previous class called Digital Logic Design. It's a pretty simple thing to help you think out how you're going to tackle your problem. And basically, you can see a state table. You have a state, and underneath this you have an output. That's in hexadecimal. That's actually just ones and zeros on the output. Here you have inputs. We have three inputs. The west, or we have I believe walk is the first bit 0, and then you have bit 1 and bit 2. These are the binary. These are the inputs that you would find that would lead you to this state. And if you find these inputs, you're led to this state, and if you get these inputs, you go down to this state. And these states lead around here. And so that's how, and actually we have the key for all of this. So walk is the first bit, west is the first bit. You have bit 0 is walk, bit 1 is west, and bit 2 is south. Then you have your bits laid out for the outputs here, and that's what you're viewing here. So basically, after you lay this out, you would to program a finite state machine in assembly, and then just enter your states, and it will do what you will command it to do, which is pretty cool. And that's all I have for you. Thank you for watching my video.